Colbert's success in code, I think that's such a compelling case, the kind of lexical retrieval you get from it with the semantic search. And another one that really interests me a lot is Colbert for reasoning intensive retrieval. I think this one is just like a really new idea.
I think Antoine has a lot of things on it, especially that he's
Yeah.
been running Browse Com Plus lately, so I think he's very excited.
Yes. So yeah. So this one it's well, the model is a bit old. Old. It's a reasoning model in Colbert, and the history behind it is that essentially when I see people releasing cool data, I just always plug it into Pilot and train a model on it. Because the thing is, since it's built on top of sentence transformer, I can just like take the existing code and data, and it takes me like 10 minutes to just try a training, right? And so there was this paper from it was Meta, which is called Reason AI, if I'm not mistaken. Yes, it's Reason AI, where they generated synthetic data to train model to be better at reasoning intensive retrieval. So to explain what is reasoning intensive retrieval, usually in the retrieval space, we focus on very brittle notion of similarity, which is like, yeah, there is a semantic or lexical overlap between the query and the document. Like there is a direct match between the two. But in the modern setup, especially in the deep research agentic setup, the notion of similarity can be a bit more complex, a bit deeper. So one example that I'd like from the Bright paper is that to solve a mathematical problem, maybe another mathematical problem that is not related but use the same theorem, it can be very useful to retrieve this one for my agent. But for current retrieval model, it's very complex, right? And so the Bright bench is all about this on different kind of domain. It can be code, it can be math, renewable energy, so some kind of domain. And they show that like the existing model were very, very bad at this. So you had like the biggest model, the top one of everything. When you apply it on this bench, they are very, very bad. And so I saw this paper from Meta, which was like, yeah, but if you generate a bit of data and you train on it, then the model improve. And I was like, okay, I just trained a general model. Let me try the data. And so I launched the data and I went into the weekend and I came back to a model that essentially was like very, very, very good because it was better than essentially all of the model that existed. And so at first I thought there was a bug in the evaluation. That's a fun fact, but I asked Orion if I was missing anything. And it turns out no, the evaluation was correct. And that's how we found out that the late interaction model, the multi-vector model, were actually very good on this kind of task. Because the final result. So this is for the fun fact, but I still swept a bit the learning rates the week after. But besides like sweeping the learning rate and the temperature, I didn't do much. And the final model, yes, it's so a modern BERT based model, so a 130 million parameter model, and yeah, it was better than all of the model up to 7 billion. So I think it's like 48 times bigger. And it was actually very, very close to the model trained by Meta on the same data, which is an 8B model, and was trained actually on more data. And so I was like, okay, but is it modern BERT? Is it what is happening? And so as I said, since it's a sentence transformer Pilot boilerplate, I can easily compare the dense model to a late interaction model. So I did the test, and actually the results are just because we are using a late interaction model. Because if you train a dense model with the same backbone, the same setup, the same data, the results are way worse. And so, yeah, that's kind of the result that we got. Again, highlighting the new capabilities of the Colbert model. Just because you are using multiple vector and that the training is a bit different, you can get like way better performance on a task that is somewhat harder. And so that was the result up until like 3 days ago. And there was a release that reminded me that there is this new benchmark, which is not really reasoning intensive, but which is evaluating the deep research capabilities, which is Broscom Plus. I think you might have seen it. And so I saw people running the benchings, and I remembered that I had this model laying around, but I should just check the performance. And so I just tried it on the Broscom Plus bench. And again, we are like better than anything that exists. And this time we actually are outperforming the 8B models, the Quen free embedding 8B models. And right now we are like topping the bench, even in the considering the custom scaffold and stuff. So it's not really about like a bias in the bright benchmark or something that we could have exploited. It's really that the late interaction model are just better at modelizing, deeper connection and deeper notion of similarities, right? Because again, the gap is so big that it's not even the same kind of game between the dense and the multi-vector model.
Yeah, it's so cool. I like, and earlier when I'd interviewed Nils Reimers about some limitations of embeddings, and he had brought up like multi-discourse embeddings. Like if you have a paragraph where the first two, the next, like the third and fourth sentence are totally unrelated to the first and two, the single vector embedding is going to really struggle with that. And that's I think the token vector is just really going to crush it at that. And yeah, that I think there's kind of two things. There's like the bright benchmark, which is like you have these really long questions, and it could be a human question, kind of like the fresh stack benchmark has this style as well, where it's like long stack overflow questions. So that's like one case where this model really shines. But then this other one where you mentioned the agent traces and the browse comp plus, I think that one is just massive because obviously there's all this work in chain of thought and having models do internal reasoning. The idea that we're going to search with that reasoning instead of writing search queries that are kind of like keyword targeted. I think.
Yes.
Yeah.
So about the long queries, I'm still a bit. I know it works. So just to mention, because we didn't talk about it, but Colbert model generalize very well to long documents. That's a known fact. It's way stronger than dense model on like very long documents. About the queries, I'm still not sure. I know it's not bad. I was still a bit unsure because on some of my tests with Bright, because with Bright you can just use the query, which is human, or you can append the reasoning trace from the LLM. And so we know the modern Colbert model benefits from the LLM trace because I run both and I've got better results. But I tried scaling the query length and I didn't. It was working better, but I didn't get the scaling that I was used to. Maybe I'm waiting for too much, maybe. But I'm still unsure because there is this asymmetry between the query and the document. Because if you have more tokens in the query, you will have more signal, whereas for a big document, you are still matching up to the number of query token, right? So I'm still not 100% sure, but it seems to work pretty well. And as you said, it seems to work well with the reasoning trace of the LLM. It kind of works out of the box, at least for Bright, it did. And actually, one of the paper that motivated me to run the Broscom paper, Broscom Plus benchmark, is one paper that trained really on the reasoning trace for the Broscom Plus benchmark. And I plan to do the fine tuning on this data and to really explore adding the reasoning trace of the model. I still don't have the results. It was like last week. But yeah, I'm very hopeful that the Colbert model do well with it because again, like right now out of the box, it works very well. So I'm pretty sure if you train specifically for it, it will be even better. And that's kind of insane to see in such complex scenarios, seeing such small model being so strong. Because the results, so we are like the number one of the leaderboard, yes, but like the result is we are around 86, I think, accuracy. So we might need another bench, right? But it was another bench up until a few days / weeks. So yeah, it's very cool to see, because again, it's a small encoder, so it runs on mostly anything, and yet you still have this kind of insane result. So yeah, I'm really hyped about seeing more results of Colbert model on the the kind of deep research ecosystem, because I know for a fact I have other signal than my own, but it's very very powerful, and I think it's if you couple this to the code use cases that we discussed before, you will have something that is doing deep research on code. And it just clicks at some point. You just have something that, like, if you couple this to a strong orchestrator such as GPT-5, you just have something that is very, very powerful and can do a lot of things just by itself, essentially.